Hi, Leland. This is your Auntie Beth, and this is a little discussion on your project that we just talked about. And so, one of the things we talked about were molecules and how we write them out. And you told me that you were familiar with the periodic chart, and we talked about water, right? And how you were going to talk about in your project that water, you're drinking water, and then you put ice in it, and that's water too. But then you also, when you boil water, and there's the steam coming off that actually you can't see. You know, you think you're seeing it. Those are actually water droplets. Actually, the actual steam is invisible. But we talked about that. And we talked about why that is. And so you told me that this is how you draw water, right? Water is H2O. And so you see your two hydrogen atoms there, and then the oxygen. And so this is how you draw it, right? But what's happening, and this is a picture of how it looks. So this was looking at it, how we draw it to show the different bonds. But this is what water actually sort of would look like, more of a picture of water. But what happens? And when I asked you, I said, hey, so what's happening? Water, it's the same molecule when it's ice, right? The molecule doesn't change. So what's happening? And you said, well, we freeze it. Well, what's happening is when you take a liquid, and this is water as a liquid, and I want you to look at those molecules. Remember, I just showed you what it looks like more in a pictorial rendition, but look at the molecules right there. Do you see them? They're not too close together. So that is water. That's a liquid, right? Well, then when we freeze water, look at what happens here. What happens to those molecules is that they get packed in a little bit closer together in a specific structure. And so they sort of crystallize. And so they have this really geometric structure there. And so they become a solid. Now, interestingly, ice floats, right? And usually a solid form would be denser and heavier than a liquid form. But the thing that makes ice interesting is, see that space in between? It makes little pockets, and so the ice actually floats. When you think about it, a solid, the same form shouldn't float, right? But that's why ice floats, so that's pretty cool. Now, what about when we take water and we boil it and steam comes off? Well, what's happening there, oops, I just went to the spaghetti slide. Let's go back to the steam slide. So when you boil it, you're adding this energy to it. And what happens is those molecules start to move around, and they start to move past each other, and they kind of speed up. And that motion, as the water boils, it comes off as steam. And again, when you see that sort of steam that you think you're seeing steam, you're actually seeing water droplets. Steam is actually invisible. Okay, so same molecule. What's happening is that its activity is different. It's how the molecules are interacting is different. So in ice, they're kind of next to each other in this crystalline formation. Water, they're just kind of hanging out there. And then steam, they're moving around, and they actually become a gas. So that's really cool. So those are kind of the three different states that you can have. Now, here's where things get kind of interesting. I said to you, well, then we can also look at the molecules that might be in a food that you would cook in the boiling water. And what would those molecules be? Well, let's look at spaghetti. Well, spaghetti's got a lot of stuff in it, but you might notice that it's got fat, and it's got protein, and it's got carbohydrate. Well, those are molecules too. And interestingly, those molecules are made up also of hydrogen and oxygen with the addition of carbon. And in proteins, they actually have some nitrogen. So this is really cool. Look at this. Carbohydrates, fats, and proteins all have carbon, hydrogen, and oxygen. So same elements there, the same elements, but when they're arranged differently, they have really different properties. So you can bring this into your discussion too. It's like, hey, they all have carbon, hydrogen, and oxygen, but they're also really different. Why is that? It's because their structure is different. And let's look at that structure. These are amino acids, and these are the building blocks of proteins. Does this look familiar to you? It should. Look, you've got all those bonds, very similar. Water was pretty simple, but look at these amino acids. And it turns out we have 20 different amino acids. And depending on how they're arranged, those 20 different amino acids can make thousands of different types of proteins. And that's really, really cool. You've got proteins in food, like the protein that's in your pasta, but we've also got proteins in our body. Our skin is proteins. Our bones have a kind of protein in them called osteocalcin. They all have these same amino acids in them, just in different structures. Just the way they're arranged is different. So when you talk about your project, you can say, this is a structure of different amino acids. You can choose any one of these. They're all different though, and that's what I think makes protein so interesting. Now, a protein is not just an amino acid. It's a whole bunch of amino acids bonded together. And you and I talked about bonds. The type of bonds that puts amino acids together, the name of it is called a peptide bond. So what I want you to do is picture these different amino acids. You don't have to know all the different types, but notice their structures there. And when you string a whole bunch of them together with peptide bonds, they become a protein. And in the case of protein in your pasta, it's probably gluten. Okay, that's the kind of protein that is. That's one of the proteins that's in there. Okay. And this is what they look like. Don't worry about this slide. This gets pretty crazy. This is showing you all the different proteins and structures that they can have. And how many amino acids long can they be? Some are maybe 40 amino acids long. Some are really, really long. Some have like 300 to 400 amino acids. Yeast has proteins in it. And this has, I think it's 344 amino acids long, okay? Now, what do you think that is? Again, it's carbons, hydrogens, and oxygens. This is fat. This is a triglyceride. So again, the same atoms, right? Or the same, not really atoms, the same elements. Elements are made up of atoms, but look at that. That is a fat. And remember, you drew me those bonds. Look at all these bonds in here and all these different things. So this is actually a triglyceride, okay? And so if you wanted to, you could draw that for your project and say, this is an example of elements that are in the pasta. The pasta had protein, had a little bit of fat. Now I'm going to show you carbohydrate. So again, this is really interesting, isn't it? Look, the exact same elements arranged differently. You see that glucose on the left there? When you put a glucose with a fructose that you see on the right, you make table sugar. So the glucose and the fructose, when those are bonded together, they make table sugar. Okay, don't worry about this. Oh, I know what I wanted to show you here. Notice on the left side, you're used to seeing things like that, right? That's how they showed you how bonds are. But that's not actually what sugar looks like if we looked at it through a microscope. It actually has this ring structure that you see on the right there, okay? I just wanted to show you that. That's just a different way of writing the exact same thing that's on the left. It just kind of looks a little bit more like what the actual structure would look like. What is this? Now you'll notice in your pasta, there's not a lot of sugar in it, right? It wasn't just those two molecules together making a sugar. It's called a complex carbohydrate. And all that is starch. All that is a whole bunch of those glucose molecules that you just saw strung together. Yep, it's just big, long chains of a repeating glucose. So where protein had different units, but they were all different amino acids. Look at carbohydrate. It's the same one over and over again, just a big long chain of that. All right. So that is just a little, what I wanted to give you some background. I maybe overdid it a little bit. I want you to tell me what you liked about that talk, what you think you could use, what you were like, wow, that's confusing. I don't understand that. So after you watch that, then we're going to Facebook again, or not Facebook, we're going to FaceTime again, and then we'll talk about how maybe you can use some of these in your project.